A dilute solution such as a 0.02 molar potassium chloride will have a density close to that of water, 1 gram per milliliter. Given this, what is the molality and mole fraction of a 0.02 molar potassium chloride solution? The molar mass of potassium chloride is equal to 74.55 grams per mole. So to start off, it is important to distinguish between molality and molarity. So molality, or little m, is equal to moles of solute over kilograms of solvent, and molarity is equal to moles of solute over liters of solution. And in a solution, we have a solute and a solvent. Let me just make that plus sign clear. So molality is moles of solute over kilograms of solvent. In molarity, it is moles of solute over liters of solution. And in a solution, we have a solute plus a solvent, right? So let's solve the first part of this problem. We have to find molality, right? So we have to find what this is equal to. So we do know that we are dealing with 0.02 moles, right? Because the molarity is written like this. So we know that we have 0.02 moles of our solute, right? So we need to somehow use the moles of solute and get kilograms of solvent. Now, how we're going to do this is we are going to assume 1 liter of solution. And what that happens to do is when we multiply this by 1 liter, right? And if we use the molar mass, we can convert this into grams, right? So this equals to 0.20 times 1.491 grams KCl, right? And well, that's going to be equal to our solute. So now we have this part, right? And now if you can start to see it, if we can somehow find the grams of solution, and if we have the grams of solute, then we can actually just subtract the grams of solute from solution and get the grams of solvent, and then we just divide by 1,000 and get kilograms of solvent, right? So now how do we get grams of solution? Well, we're going to use the density that was given, 1 gram per milliliter, right? So 1 gram per milliliter, in other words, 1 gram over 0.001 liters, right? Because 1 milliliter is equal to 0.001 liters. And we're going to multiply that by 1 liter because we're assuming 1 liter of solution. And that's going to give us, so 1 divided by 0.001 is equal to 1,000 grams of solution. So now we have this part. So if we plug all this in, is equal to 1.491. This is our solution, right? And this is our solute. And now we just need to get our solvent, right? And all we have to do is multiply both sides by 1.491. So 1,000 minus 1.491 is 998.509. And if we divide that by 1,000, we get 0.001 998.509 kilograms. So this is how much solvent we have, right? So now we can solve for molality, because we know that we're using this many moles of solute. And we now know the kilograms of solvent. Right? And this is going to give us 0.0200298, but since we're using 3 sig figs, we're just gonna keep that as 0.0200 molality. This is the molality. Now let's go on to the next part of the problem, which asks for the mole fraction, right, of the case of this KCl. So if we're trying to find the mole fraction of the KCl, we're gonna put the moles of KCl, total moles, right? So we know that the moles of KCl is just this. So 0.020200 moles KCl. Now what is our total, right? What is our total moles? Well, the total moles is actually dealing with the total moles of the solution. So we know that in our solution, we have 0.0200 moles KCl, right? But we also have a solvent that we have to deal with. We know that we have 998.509, sorry, I should probably put grams right here. Grams, that looks horrible. So we have 998.509 grams of solvent, right? We know that. And we converted that into kilograms by dividing by 1,000. So how do we convert this amount of grams of solvent into the moles of solvent? Well, we have to create another assumption, and that is that we are dissolving the solution in water, and therefore our solvent would be water. So we're going to create a second assumption, being that we are dissolving in water. So we're going to assume that our water is our solvent. So with that, we can say that this 998.509 grams of solvent is essentially 998.509 grams of water. So H2O, and the molar mass of water is 18.01528 grams per mole, right? 18.01528 grams. Which is going to be equal to 55 4 3. So now we have 55.43 moles. So all we have to do now is just evaluate this. 0.020 plus 55.43 is 55.45, and this is just equal to so since we have 3 sig figs, then this is just 3.61 times 10 to the negative 4. And that is our mole fraction. And that is how to find the molality and the mole fraction in this problem.